Hello again. This is Math 2245 coming to you from the College of DuPage. The title of this lecture is Midterm Solutions and Commentary. This is useful hold or fold data as the dropping deadline dawns. And as you know, the dropping deadline is July 24th. As always, please be attentive while watching this video. By way of introduction then, you can find out your grade at this moment in time to date by taking the average of the midterm HSA and the LSA year-to-date summary. Again, as I discussed, I was really quite generous over here to help students come up with perhaps a credible average. What happened here is this is how you should view those numbers, the average of those two numbers. So there's A's, B's, C's, D's, and so forth. And realize that going forward, this is 2/3 of your grade. The final will count for at least 1/3. There is an upside opportunity on the comprehensive final, but as you make your decisions to hold or fold, please be realistic. And as you know, again, July 24th is the final day to withdraw. Now we're going to go through the solutions now to the exam. There were 12 equally weighted problems, and you had an hour and 50 minutes. And there was one attempt on this, and you were also dealing with the accommodations. You dealt with the proctors on the accommodations, either in the brick and mortar facilities or in the virtual testing center. Question 1, you were to find all solutions to the following system of equations. You can see that the first and third are multiples of each other, so there are going to be an infinite number of solutions, but I wanted you to find what those solutions were, not just say there were an infinite number. So you had to specify what those solutions were in order to get full credit on this problem. And so x2 and x3 were free variables, and x1 has to look like this. So there are different number of solutions, but this was the form. You had to have both of these to get full credit. Number 2, you were to find all solutions to the following system of equations, and we had x, y, and z. And this also has an infinite number of solutions, but there are not two free variables. There's one free variable. And so z is a free variable. Y is going to be minus 7z minus 8 over 7. And x actually has a number. It is 5 over 7 because the z's cancel out. Number 3, you were to find an LU factorization for this matrix. You might remember that I was, when I was lecturing on this, I called that part 1, and I never really got along to talking about part 2, and then I unfortunately picked something that we had to go to part 2 for this. Now you see what really happens is you have to have pivot elements as you're going through this to do the LU factorization. So that sometimes requires you to do what's called partial pivoting, and that is moving some of these rows around. We really didn't discuss that, but that's actually time around. So you start with the initial matrix, and you would crash and burn if you tried to do an LU factorization on this. But what you can do is exchange the first and third rows using this permutation matrix, and then the permutation matrix of A is equal to LU could be factored this way, L and U. Since I didn't fully discuss partial pivoting, and this was my fault, I gave all students full credit on this problem. But this was the LU factorization after the partial pivoting. Question 4, you define the inverse of this matrix. It had a bunch of fractions in it. And so what you do is you start with an augmented matrix where you have the matrix over here and the identity matrix here. You do row operations to turn this into the identity matrix, and this is the inverse. And so the inverse you should have gotten was 1, 2, minus 1, 2, 1, 2, minus 1, 2, and 1. Question number 5, you were to calculate the determinant of this matrix. And the determinant is 65. Question 6, you were to find a basis for the null space of this matrix. Now, it was important that there was this row of zeros here, and that did influence your answer as well. So you see, we were already in row echelon form, so all we have to do is we have to solve the system of equations where we have x1 through x6 times that is equal to 0. Well, turns out when you do that, x3, x1, and x6 are free variables. x4 is 0, and x5 is minus 2x6, and x2 is that linear combination as well. So you put that into a matrix and you split out the free variables, x1, x3, and x6, and you do a little bit of arithmetic with this, and so you find out that this one, and this one are certainly linearly independent of each other, because you can look at where the zeros are and you can discern that. And so that means that the bases are these three vectors. Question 7, you were supposed to find a basis for the column space of the following matrix. So what we do is we row reduce it, and we find that there are pivot elements in the first three columns. That means that the first three columns up here are linearly independent one with each other, and so these three column vectors are basis for the column space. Question 8, you were to determine if these were linearly independent or not and explain your answer. You could have set up this as a matrix and taken the determinant and found the determinant is equal to 0. That means that they're not linearly independent. There are other ways, just using the definition C1 times this one plus C2 times this one plus C3 times this one is equal to 0. Gives rise to these equations, and you can solve this and get a non-zero equation, non-zero solution rather, and that means these are not linearly independent. But you had to explain your answer, not just say, not basically giving a guess without justification. Number 9, we were looking at a transformation defined by t of x equal ax, where a is here. We ask if this transformation 1-to-1 and explain why is true. Again, the explain was a very important part of the answer. It was not just a guessing if it was 1-to-1. And you see this vector and this vector both are mapped to this with a linear transformation, but the two vectors don't equal each other. That means it's not 1-to-1. Question 10, you had this going from R2 to R3, and this is the matrix that you have that were that's defining T. And I ask, is this onto? Now, some students thought I misspelled 1-to-1, but we talked about onto functions, and so this was truly onto. It was not a typo. But you have to explain why your solution is true. And I just picked a vector here that has 1, 2, and 3. And you see, if I take x1 and x2 and multiply through by this, I get that this is x1, x2, and x3. So you see the first and third have to match each other. That doesn't happen up here, and so this is not onto, because we found a vector in R3 that wasn't the image of anything in R2. Question 11, we were to find an elementary matrix that multiplying on the left on A would give you B, and find another elementary matrix. They really were two problems here, A and B. Some students only did one of them. And find out elementary matrix E, such you could multiply on the left and on A and get C. And so what you were doing was you were if you multiply E times A, you'll get B. And again, here what we're doing is we're switching the first and third rows is what is happening there. With this matrix, what you're doing is you are keeping the first two rows the same, but the last row is minus 2 times row 1 added to row 3 becomes the new row 3. And so these are this is the answer to the first one, this is answer to the second one. And in 12, we talked about this commutator, and we ask, is it true or false that the commutator of AB is equal to the commutator of BA? And this is the definition. Many of you went through discussions of this. Some of you asserted that it was true because you said matrix multiplication is commutative. That's not really true. If you take these two things and set them equal to each other, what you can observe is that the commutator of AB is the negative of the commutator of BA. And so the only time that those two are going to be equal is when they're 0, and that means that A and B commute. I gave a counterexample here where A and B didn't commute, and that would have been a complete answer to the problem. It is useful to think about these things, though, because the final will be comprehensive and it will cover some of this stuff and some more stuff. And soon we will be talking about the content for the final as well, but it will be comprehensive. Again, an upside opportunity for you. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself and of each other. Self-care is important, and we're all in this together. God bless you all, and if you do need to make a decision to withdraw from the course, you should do that. Otherwise, engage and do well on the final. Please take care. God bless.